Okay.
Whatever the message is.
All right, Ivo and I, my co-chair, would like to welcome you to the COSE working group here at IETF 124, either in Montreal or, as some of you are, here virtually. There's a new note well. It contains some material you're familiar with, but probably some new material that you're not, so you're all encouraged to read it and use it to inform your interactions with your peers. If you are in the room, please sign into the in-person meeting tool so that you will be able to join the queue and so that you're in the virtual blue sheets, for those of you who remember that methodology. Those of you who are remote, I don't have to tell you to sign in or else you wouldn't be here. For everyone, whether you are virtual or remote, please inform people who you are. I know some of your names, some of you know some of your names, but particularly for the note taker, it will be helpful. Speaking of which, we need a note taker. There's links in the agenda for where to take notes. In fact, ideally, I would like to solicit two because it's a collaborative editing tool and you can tag team and improve each other's notes. Who would like to volunteer on this fine afternoon? Thank you. Say your name. Jonathan? Can I get a second helper for Jonathan? Do I have to walk the room?
I can assist. Chris does.
Thank you, Chris. I appreciate it. I know that you have time here, but that's great.
Jonathan will take notes when I'm talking.
Okay, perfect. We've just covered this agenda item. We have 2 hours. We will probably use a lot of it. We may not use all of it. I think some of the decks that I've seen probably didn't expand to completely fill the time slots, but who knows what will happen in the microphone queues. So with that, I believe it's time for Hannes. Oh no, status updates. The dilithium draft is with the RFC editors. It's in the RFC editor queue. That will be published as MLDSA. The code points, both for COSE and JOSE, are allocated. It's in production use in some contexts, including in some FIDO authenticators. So good job, everyone. Merkle tree proofs is at the RFC editor queue. Hash envelope is in the RFC editor queue. Timestamp header parameter is in the RFC editor queue. I'm seeing a pattern. Whereas I will talk about the BLS key representations draft, which is largely waiting on some other drafts. And we've requested publication for CBOR encoded certs. Now there is some new incoming proposed work, which we'll talk about, which is in the agenda, but good for all of you in advancing as much work as we have lately. And with that, I'm going to switch decks to Hannes' deck. Uh-oh, how do I stop sharing this? Evo, do you know how to override me? Yeah, the share button tells me all the slots for this kind of media are taken.
You may have to stop sharing first.
Yeah, that's what I'm trying to figure out. I thought the share button would do that.
Now it worked, yeah.
Okay, there we go. Thank you.
Thanks, Mike. Thanks, Ivo. Hi, everyone. So I wanted to give an update to the COSE HPKE work. I've been talking about this a couple of times already, so you know the document and you know the authors. I think Lawrence, I saw him, I believe, in the room as well. And the others are busy somewhere else. Next slide. So I think we had a pretty good meeting in Madrid, and we made a couple of, well, we had this contentious issue on how to deal with the context information, and we finally decided to follow the recommendation that Lawrence provided and put this new recipient structure together and included that in the info parameter as Sophie suggested. And so that change has been made. And of course, there was a normative change to the specification, and that required an update to the code. And of course, to all the examples in the specification, which Daisuke and I did. Those are the two implementations we used for that. And we made sure that they interoperate. So I used, my code was based on Lawrence's COSE library, and Daisuke used the Python implementation. So that's what you see in the document. And of course, it looks like a lot has changed because the changes are basically in all the examples. We also took into account the other recommendations or suggestions in the feedback. One was related to the use of the APIs in the HPKE. And for all the time, we've only been focusing on the one-shot APIs, but we didn't explicitly say that. And so we clarified this issue because there's also a sort of a different API supported. Currently, we still support the RFC 9180, which is the original HPKE specification, and not yet the document that is being worked on in the HPKE working group, which is an update to this. We'll see which document hits the RFC editor queue first, and if that this current HPKE version, this BIS version, hits the editor queue first, we would do we basically replace the references, but this has no impact on the actual implementation or so, because none of the features that have changed in the currently worked on HPKE specification were relevant for this document. So in some sense, it doesn't matter what the reference is. We also, of course, updated the recipient structure description as we made changes there. We changed some of the fields to make them more readable, and we also removed the COSE Mac support. So a lot of change. And but on the positive side, if we go to the next slide, it's we are, in my opinion, with these changes and with these decisions, pretty far along, and that's why I'm not going to use my 30-minute slots. I hope I see only one what I call a trivial open issue, namely Matt from Apple had requested an algorithm registration, a combination they are using at Apple, which we wanted to include here as well. So this is just an entry in the basically then the IANA registry and not much else. Yeah, and so this is a very sort of recent open issue. So we're trying to address this with a new BR this week and submit a new version. But then I would like to request the chairs to issue a working group last call with those changes and see whether we can actually move forward with this.
So I have been an active reviewer of the document, and chair hat off, it's my belief that it is now mature enough to go to second working group last call. But chair hat on, is there anyone in the room or online who would like to speak to the possibility of issuing second working group last call after the additional algorithm that Matt from Apple has requested? Hearing none, Hannes, please proceed to address that issue by adding the algorithm. I'll note that that algorithm was already added in the COSE HPKE specs, so this would keep them aligned, which has been kind of a meta goal between the two working groups. Once you have done that, I believe we will start second working group last call.
Sounds good. And thanks to the group, and also thank you, Mike, for your help reviewing the document and helping us get this sorted out, because it was a somewhat long journey with this document, much longer than I expected.
Indeed.
And if someone is also currently updating their implementation, it would be nice to reach out to me or also to Daisuke so we can do some more interrupt testing. Yeah, and with that, thank you.
Thank you. Let's now, Ivo, can you switch us to the other presentation? All right, I'm going to take chair hat off and be virtual Hannes with Hannes in my back pocket. So, as you know, we had 3 post-quantum drafts in the working group. The dilithium draft has become MLDSA and is in the RFC editor queue. This is the Falcon draft, which Hannes agreed to pick up as a new editor. So let's talk about that. And full disclosure, Hannes wrote these slides. I have read them. So Hannes is now lead author. Thank you for stepping up to the plate, Hannes. As chair, I will say we did do a poll in Madrid about whether there was interest in continuing this work, and there was. And people stated reasons in the minutes and at the mic why they wanted to continue it. Therefore, we asked for volunteers of who was going to continue it, and Hannes stepped in. So thank you, Hannes. So now, chair hat off, presenter. So the title was changed from Falcon, which was the kind of colloquial name used in the submission, to FN Digital Signature Algorithm, and we updated the references. There have been a number of editorial improvements. You can see them by reading the diffs. And because there was a lot of common text in the MLDSA draft, the dilithium draft, and the Falcon draft, it's unsurprising that when MLDSA went through IESG review and area reviews, that textual improvements were suggested. Ori and Hannes were diligent about applying those updates not only to the MLDSA draft, which was the subject of the last call on the IESG review, but to this draft and the subsequent one. So there's examples in the draft. This is pulled out. There's a JSON web key using the brand spanking new FNDSA 512 algorithm identifier. And there's a signature header, in this case for a JOT. So next, the authors believe that they want to add some more meaningful examples of use and test vectors for both Jose and COSE, which this seems very reasonable. We'll need to update an implementation to do that. Hopefully, we will get more than one to validate the results together. And aspirationally, the authors believe they will be ready for last call in 2 months. Hannes, I believe you're still online. Would you like to add anything to my exposition of your slides? And then we will take Scott.
No, thank you, Mike. That was well said. The implementation, so I was working at the hackathon, was hoping to get also an implementation for this document and also the next one, the SLH DSA. But it took me too long to get the implementation working for the MLDSA. And so I need a little bit more time. Of course, if there are other implementers, again, would be happy to do interrupt testing with them. That was just, I think one weekend is not enough to write an entire implementation. So, yeah.
Scott.
Yes, NIST has not finalized the FNDSA, and they're extremely unlikely to be able to do so in the next 2 months. Are you going to basically do a working group last call and then hold it before, when depending on NIST, or are you going to say standardize whatever FNDSA is at the moment?
No, but obviously we will wait for NIST on this, but at least my expectation is that the implementation work won't take too long. So currently the examples are basically taken straight out of the document, and which means like they are non-workable. They are just sketches of ideas on how this would work. And I would like to have some real examples in there that someone could really use also as test vectors. So that was what was meant with the 2 months. But then it would just sit there and wait till NIST finalizes the work. Does that make sense to you, Scott?
Yes.
Cool. Okay.
Proceed.
Sophie Schmiek, Google. Even with test vectors, we currently don't even have a draft standard for FNDSA. So as long as you are willing to accept that they will change. And FNDSA in particular, I would not be surprised if implementations take a bit to actually come about. It is a very complicated algorithm to implement. Yeah, I've done it myself. I didn't like any of it. It will take a while until you see algorithms. But yeah, like in the end, as long as you're fine with saying like whatever NIST comes up with once they get money to do their work again, that should be fine.
Yeah, definitely aware of that difficult situation, and yeah, happy to wait and then to update the code and the examples again. We are, so for embedded implementations, we are in general a little bit behind anyway on the implementation side. So it's probably not a big deal. Yeah. And I think that it's like also for the next presentation, the SLH DSA, that it's the same is true. I also need to update that implementation. So I need some time as well.
Okay, Ivo, can you take us to the next presentation, please?
I think the Philip is in the queue. Do I see
Okay,
that?
thank you.
Thank you, Hannes. Thank you, Michael. Sorry, thank you, Mike. I had a very similar point about the timeline. I looked today through various trackers and various crypto libraries and their plans for implementing FNDSA. And in particular, OpenSSL doesn't have currently any plans for the support or to start support until FIPS 206 actually comes out. The latest presentation that I was able to find pretty much said 2026 is a stretch and it's not likely to come any earlier than early or mid 2027. Now that doesn't take into account the government shutdowns and etc. So my question was also, are we going to hold off the draft until the FIPS reference becomes stable? Because currently the reference just points to the announcement that FNDSA has been selected.
Yeah, I think it would be a mistake to publish this before the NIST specification gets published. I think we would cause more problems than it helps.
Yeah, I agree.
And I am once again acting as virtual Hannes with the real Hannes backing me. So the Sphinx Plus draft was in the same quasi-abandoned state in Madrid that the Falcon draft was. And as I said, Hannes agreed to pick that up because there was interest in continuing the work. The status update is pretty familiar and parallel. Hannes became lead author. We changed the title to the title of what we expect the algorithm to be called for real. Made editorial improvements, especially those informed by IESG feedback and area review feedback on the dilithium draft, the MLDSA, which shared a lot of text with this draft. There are examples, both of, in this case, a CBOR web key. That's very diverse of you, that we have both a JWK and a CWK. And we have a COSE sign example rather than a COSE signing example at JWS. We want test vectors. Hannes can speak about updating the implementation if he would like. And there's again the aspirational statement about when he might be done. Hannes, take it away.
Yeah, there's not that much to say other than the situation for this document is much better, like from a timing perspective than the previous document we just talked about. It's also something that fits nicely into the scope of this group. We've had discussions about this algorithm in context of firmware updates a number of times already over the years, and so I think that should be pretty obvious on what the use cases here are. Yeah, again, the code updates need to happen because otherwise the examples are are just not meaningful. But otherwise, it's pretty straightforward, I would say. That's a good thing, I believe.
Yes, it is.
Philip is again in the queue.
Thank you. There was a message on the list regarding upcoming or new or updated parameter sets which deal with the inefficiency of SLH DSA. I tried going through an implementation today based on OpenSSL, and I was running benchmarks comparing this to traditional ES256 and post-quantum MLDSA 44, and I was surprised. Well, not really, because it is alluded to in a number of documents that the signing performance of this is horrible. So I would like to question I know there aren't possibly current parameter sets better than the ones that were chosen, but I'm looking at signing throughput in the single-digit numbers as opposed to thousands in the other algorithms. With verification, it's not that terrible, but we're still talking about a dramatic decrease compared to even MLDSA. So first question would be, what about the alluded to parameter sets that would improve the performance? And my second point would be that you're making a registration for 3 parameter sets to use with COSE ALG, so to actually make them use for signing and verification. In the Web Crypto modern algorithm specification, we would, in a follow-up, make a request to register all the remaining parameter sets. However, only for use with JWK for representation, not for use with JWS.
Yes, Sophie Schmid, Google. Yes, the signing performance of SLH DSA is atrocious. I think Boring SSL manages to produce 7 signatures per second. You can optimize it a bit further, but not by much. That is kind of the point of SLH DSA. Like, you don't want to use SLH DSA even with the changed parameter sets in a situation where you are like very performance critical. The point of SLH DSA is that it, for one, has a very, very conservative security story, and for second, can be implemented using only hash functions. So it's very attractive for things like firmware verification, where you have very long-lived public keys and where you may only have silicon that supports hash like SHA-256 or something. It is not attractive for any like interactive use case. That's not really what the algorithm is for. The alternate parameter sets lean even heavier into that. Like, they have higher performance, but the main thing that people have been optimizing, as far as I know, is the size. Scott might know more details. This is traded off with the number of signatures that you are allowed to create during the lifetime of the key.
Mm-hmm.
So this again means this is a scheme that is used for things like firmware verification, where you have like maybe a new firmware every day at most, and so you have like maybe 1 million signatures total. So this is not something that you realistically want to use in things like attestation or any other like high throughput use cases. It really is for firmware verification in similar use cases where you are not performance constrained.
Okay, that's fair enough. Thank you very much.
Yeah.
Thank you for that.
Yeah, I think Sophie said it all. We can definitely think about registering additional sort of parameters if that's useful. The current parameter set is basically what people have been talking about in the past, and for the use case that was just mentioned by Sophie. So yeah, if you have a strong opinion about the parameters, happy to chat with you, Philip.
I think it's all right. The explanation given by Sophie is absolutely sufficient. It would be great if at all possible, that this the intent for these existing is reflected in the draft for readers, so that we don't get people, implementing this into OpenID Connect providers, etc. Because that
Okay,
would be
good point. Yeah.
Sophie
Yeah, I can
left.
definitely add some text, some motivation about the firmware updates, which was work done in a different group in the IETF, in the suit working group, which is going to meet later this week. So yeah, I can do that, no problem.
And did the note takers capture some of the color commentary on when the algorithm would and would not be appropriate to use?
for complete test. I will paste the benchmark that I ran today into chat
Yes.
for those
the
who are
other one
interested.
did.
Thank you. I don't see anyone in the queue. Hannes, unless you'd like to say something else, we can.
No, enough said. Thank you all for your time.
Okay. Ivo, can you pull up the key representation draft slides? Now I'm an individual contributor again, this time of a draft that I'm an author of. So we have defined key representations for use with the BLS family of algorithms. But people have been implementing, including Emma Lundberg in Sweden at Yubico and David Waite at Ping Identity in Denver, and there's been some others. And they said, gosh, as much as the current key representation says you use the uncompressed XY coordinates, that's not what people do with these curves in practice. There's this thing called a Zcash encoding, which has a couple special bits that have special meanings, but it's in use in the wild when people are using these algorithms. Furthermore, and this is what tipped the scale for me, even though I like uniformity and like people to do things the same way, it was pointed out to me that the BBS signature draft not only normatively defines the Zcash point encoding, among other places, but it uses it internally in some of its computations, in which a representation of the key is included in the cryptographic outputs, or the cryptographic computations resulting in the outputs. Therefore, any implementation of BBS has to have an implementation of this point encoding, at which point I gave up and said, okay, let's switch back to using the Zcash representation, which is for a public key, a single value rather than the pair, which meant we went back to using the octet key pair key type rather than the EC or EC2 XY key type. And then, again, because we were implementing and we were trying to produce examples, which Emil gets a great deal of credit for, he said, oh, well, the Zcash encoding is defined both in BBS and in the pairing-friendly curves draft for BLS 12-381, but it's not defined for BLS 48-581. And so Emil wrote up an appendix in our draft saying, well, this is how you would represent the parallel point encoding for that curve. Now, there's a separate question, is this the right place for that if we decide to keep it? The answer is probably not. And I'll talk about that when I'm on the next slide. So there's a number of related drafts which were talked about as a group in the CFRG yesterday. One is there's the pairing-friendly curves draft, which Yumi Sakimi, as lead author, presented, again, it having been on hiatus for about 2.5 years, that there's intent to resume and finish that, and there was a request for collaborators in finishing the text. That was another place where the Zcash encoding was defined, or is defined, but only for BLS 12-381. And I had a hallway conversation with Yumi saying, if this looks like it's going to progress in time, maybe we move that appendix there. But also there's a point of discussion which we should have probably both in this working group and in the CFRG about whether the Zcash-like encoding that Emil so diligently created for us is what we want to do, or whether we want to go back to XY for the other curves. I'm agnostic to that. I would like input from implementers more than anybody else. Then there's the BBS signatures draft. It needs a key representation. It's a matter of public record that this has been stalled waiting for a response from the cryptographic reviewer. There was a review, the authors updated the draft, and we've not gotten confirmation that what the authors did to the draft satisfied the review. Meanwhile, and John Bradley is on the call, or was, got ambitious and talked to Dan Benet, who was the lead editor for the BLS signatures draft, which our draft also has an informative reference to, and said, hey, this is valuable, we should finish it. Can I do that? And Dan said to John, sure, go do that. And they communicated with the CFRG chairs, and John has published a new draft of BLS signature that's not 2.5 years old. So there is a lot of progress, or intent to make progress, at least on this cluster of drafts. Meanwhile, the JSON Web Proof drafts in COSE also depend upon this stack of things. So the status of this draft is it's kind of waiting in this queue of stuff for the stack of stuff to finish. In fact, it's probably in the minutes, a CFRG chair yesterday said, well, BBS has a deep chain of dependencies that people are waiting to be resolved. And it's really time to get to it because people want to deploy this and use it in practice. And so there was intent stated yesterday, at least during John's presentation on the draft he took over with Dan Benet, to call a virtual interim on the BBS family of drafts in the CFRG. There's others that I didn't even mention just because I don't have a chain of dependencies on those, but there's other BBS drafts that others do. With that, John, I see your smiling face.
It's probably artificially generated if it's smiling. That should have been your first guess, along with the
Oh, and
6
it's
fingers.
wordless, so it's clearly an imposter.
Yeah. So I was just going to say that I've been trying to excavate the old issues in BLS signatures. So this isn't the first time that where the key representations should live has come up. We probably need to having it in pairing friendly curves. I know, it's in BLS signatures now for BLS 12. We should probably have both curves written down the same place in some coherent way. I'm not sure that I have a feeling that the key representations are more closely tied to the curves than the algorithm. So I think that might make sense. If we can keep progressing these things and get them aligned, that would, I think, be a good thing.
Yeah, and as an individual author, I intend to follow up with Yumi, who's the lead author on the pairing friendly curves draft, and see what her view is and what she thinks the next steps are.
Right. So we should probably actually get together some sort of mailing list and or group and go over some of these things and try and push the CFRG for a virtual interim so that we can hopefully make progress rather than have this be a great in theory, but thin on the ground in practice, at least from a verifiable credentials point of view. I mean, there are other things like Zcash and some blockchain, I understand, lots of things actually use this, but it seems that everybody just kind of stopped at some point in the standards process and forgot about it because they considered it to be done.
Right. Well, I know you'd mentioned to me that Dan considers this to be established cryptography, so.
Yes, he deeply objected to me not including it in the established cryptography. Things that are innovative to his mind are the post-quantum applications of this and other sorts of algorithms that BLS has kind of been there, did that 20 years ago.
Okay, thank you. Does anybody else want to speak at the queue? If so, please join. Otherwise, we will carry on. All right, I will sit down. Thank you all. Chris, I hand you the clicker.
I have a clicker. All right. I come back once more to discuss composition claims. This draft has kind of been sitting out there for a little while. I put it out there, we talked about it, and then, it was overtaken by events. We worked on some other stuff for a while, but there is now some work that depends on this. So I'd like to remind people what it is, where it's coming from, and why we need it. So motivation here. CWTs encode sometimes complex policies. They are increasingly used for policy-bearing tokens, not just identity-bearing tokens. Although, as you will observe, the work presented here will apply to both. This is general purpose, and we need a flexible way to express these complex policies. claim sets in general are an AND operator, right? So if you have 10 claims, all 10 things must be true. Multi-value claims, on the other hand, are generally an OR operator. One of these things must be true. So for example, if I have a token that looks like this, obviously this token is too small to be useful, but it demonstrates. I'm an issuer, issuer.example, and I have an audience claim with 2 elements in it. Whenever this token is acceptable, we know that both the issuer and the audience claims are true, and that at least one of the audience values is correct. So you don't have to identify with both party A and party B. You only have to identify with one of them in order to consider the token acceptable. However, this leaves us with things that we have trouble expressing. Some claims do not have multi-value support. For example, you can't say that the subject is Alice, Bob. That would mean this subject is Alice or Bob, but I'm not telling you which. That's not useful for some circumstances. It's very useful for other circumstances. Sub doesn't have multi-value support. You can't have duplicate claims, which is to say, you can't say the subject is Alice and the subject is Bob. This would mean the subject is both Alice and Bob. This is not valid CBOR. So the composition claims draft introduces logical claims. For example, if you have an OR claim, OR is spelled on the wire as simply an array of claim sets. So we could say OR, and the first claim set is the subject is Alice, and the second is subject is Bob. That means the subject is Alice or Bob. And then the exact same thing with and. The subject is Alice and Bob. Also, some claims are difficult to invert. For example, to declare a token that is valid anywhere except a particular location, we have a NOR claim. NOR is more general than not. You can use it with one element. It works fine. You need and, or, and NOR. Very straightforward. I'm not going to go through this, but you can see the claims build up to make fairly complex policies. What we found in practice is that people were doing things or trying to do things like this by simply having a whole lot of tokens and saying that one of these tokens needs to grant you access. And because of the way conjunctions of disjunctions work, you can almost always decompose this into lots of tokens, but you wind up doing a whole lot of cryptographic work to validate each of those tokens, which are all, generally speaking, signed with the exact same key. Also, we need extensibility for the same reasons that we need these complex claims. Generally speaking, unknown claims are ignored. It depends on your profile, of course. Some profiles of CWTs are specify specific claims and you can't add extra ones. Some of them say ignore extra ones. But in general, unknown claims are ignored. Profiles have to specify what's required. But sometimes we need more flexibility. Having the crit claim there, and it's just an array of claims that must be present and understood, allows for these to be extended and allows us to really benefit from the alternation provided by an OR claim. So how does this differ from the draft that we proposed last time? Well, first, I've removed the enveloped claim from the draft. I still think it's useful, but there was no energy around codifying it, and so I've removed it. I have a lot of energy and people who need these logical claims, and so that's what I'd like to move forward with. I added a lot of examples based on feedback in the room. People didn't understand exactly how this was supposed to work or why it was supposed to work, so we've added examples to the text. and I fixed a number of issues noted on the list. Importantly, the mock working group has adopted CAT for mock, most recently renamed C4M authentication, and that requires composite claims so that we don't have to have dozens of tokens.
So, Chair, interrupt. What does mock do?
Media over quick, except that they just renamed mock media over quick to just mean mock. So it is a quick based transport, but you can put things over it that are not media. I am seeking adoption of this so that we can use this over there. And I think that this is the room that has the people and the brains in it that can best criticize this work. Questions?
I will ask one of my standard chair questions. Who has read the draft? I read a precursor. Lawrence, you're in the queue.
Yeah, Lawrence Lundblade. I have not read the draft, at least not recently, maybe a while ago, and I didn't have any adverse reactions to it. My question was, have you looked at the CWT redacted stuff, the privacy stuff, and if there's any relationship to that? I'm just throwing that out there. I don't know. Really.
That's an excellent observation. Selective disclosures can be used to accomplish much of what the enveloped claim used to be written for, and has reduced the value of such a claim. And hence it was removed from the draft. So the draft only now has the AND claim, the OR claim, the NOR claim, and the CRIT claim left in it. So you probably read the original one that still had the enveloped claim in it. That's out.
Next standard related chair question. Who is willing to read the draft? Please go to the mics and speak your names so the scribes can capture your identity or an identifier for you.
Lawrence will read the draft.
Mike Jones will read the draft.
Nicole Bates.
Nicole Bates will read the draft.
Felipe Ventura will read the draft.
Yug Shah will read the draft.
All right, that's a good set of reviewers. Refresh my memory. There was a draft that came to me, I'm not being a chair now, as a designated expert that registered claims for another standards organization that did want to use this. Can you give us that context?
Absolutely. It is in fact useful. So the context is that the Common Access Token, which was published by the CTA, the Consumer Technology Alliance, if I remember the letters correctly. This is designed for, it's a standard, it's a policy bearing bearer token, uses CWT for distributing media. It's used anytime that you want to not have to, you want a third party like a CDN to enforce your policy for you. And in fact, it is that CAT that was just adopted by the Media Over Quick working group. The CAT, that working group actually went through all of the work to define these logical claims and all of that. And then they got to the end and said, but these don't really specifically relate to our specific use case. We need them, but they are completely general. And it is more appropriate to send that work to the IETF. So they sent the work to the IETF and said, IETF if they're willing, if you can get the energy over there, that is the more appropriate venue for that particular work. And so, yes, the Common Access Token expects these to be registered, and it expects to issue a revision the instant this is published, should it be published, and to update and incorporate that into the Common Access Token profile, which is precisely what the mock group is also depending on for the exact same reason.
That's good context. Thank you. Would anybody else like to go to the queue? Okay, it's my request as chair that those who volunteered to read try to do so before the holidays kick in, so that in December sometime, Ivo and I can make a judgment call about whether to ask for adoption or whether to ask for an updated draft incorporating feedback received in those reviews.
I look forward to it.
Thank you for your presentation. Okay, I'm back as an individual like a bad penny. There's work I've done with several other colleagues, primarily Emma Lundberg of Yubico in Sweden, which we've talked about the previous two IETFs, which as of Madrid became called split signing algorithms for COSE. Since we last met our heroes in Madrid, we continued incorporating feedback we received from this working group and others about basically making the mission of the draft super clear to people. People were surprised 8 months ago when we showed up with this, and we didn't do the best job of conveying non-surprise that this is a technique that's commonly used. The notion that you might have an algorithm that you do something in the application to do part of the signing step, and you do something at the private key holder to do the rest of it is not novel, and we'll talk about that. But now we do a much better job both in the abstract and the introduction describing that that is not novel. We added registrations for two prehash algorithms, which have been defined in the literature but had not ever been registered for COSE and COSE. There's related work, asynchronous remote key generation, or ARKG, also by Emil and the esteemed John Bradley, where they'd updated a parameter name. In an example, we refer in one part of our draft, we refer to that, and so we tracked that change. There's now security considerations, another sign of the draft maturing. And an achievement I'm personally proud of is that Ori Steele and I last week completed the journey to an RFC for a draft called Fully Specified Algorithms for COSE and COSE, which not only defines fully specified algorithms for EDDSA and some other things, but it makes it the law of the land that henceforward you will only register fully specified algorithms. And that's done. That was an aspiration we started on 2.5 years ago. It's now done. This draft references it. There's other IETF drafts, OpenID, W3C, and FIDO drafts that reference it. So enough blowing my own horn. Why split signing? Why would you have the application do part of the signing rather than just do it all where the private key is held? Well, the place holding the private key may be on a very low bandwidth connection, like Bluetooth low energy, where you can't send, using Hank's favorite example, an entire cat video over Bluetooth LE or over NFC. It also may be the case that your device may have limited computational ability. It may be running off of a permanently installed battery rather than a power grid. And so you want to limit the amount of computation that you have to do. And the good news is, and we've reviewed this for 8 months with you, many signing algorithms, not all of them actually are decomposable that way. Typically by having the application hash the data, and then you perform the second step at the key holder on the hash data. The draft goes into more details that are algorithm specific. And yes, this is algorithm specific, and not every algorithm is decomposable. We call the two roles the digester and the signer. And yes, you have to trust both of them to get a good signature. The result is that these signatures look exactly like signatures produced by the registered single-party algorithm. They're indistinguishable cryptographically. It's just that the engineering decomposition of how the steps were performed to do the signing has a split point. As I've already said, this is not new. Smart cards do this. HSMs sometimes do this. Sometimes your private key is held in a device with limited bandwidth or limited processing capability. I already said that because I'm speaking rather than reading my slides, but it's okay. I'm reinforcing what I said earlier. And it is used in practice, among other things, by some prototype FIDO authenticators that one Yubico has made. And we're trying to have the W3C standardize a signing extension where you can utilize this. So this is the motivating use case. The next number of slides you've seen before. We've updated them where they weren't exactly right anymore or applicable. But there's this thing called the WebAuthn signing extension, which will let you sign raw data with a FIDO authenticator or with a WebAuthn authenticator. But guess what? Some of those things you're talking to over a very low bandwidth channel, like NFC, which is why split signing is useful, to be able to nonetheless sign big blobs of data without sending the big blobs of data over the limited bandwidth connection. And this is used in the WW Wallet digital identity wallet, which this is new data. It won the, I'm not on the right slide, but I'll say it anyway. It won the German Funky wallet competition for digital identity wallets in Europe to be used by the nation state of Germany. So that's a big deal. And the WW Wallet implementation uses this. So there is application motivation to do this work here, in part because FIDO and WebAuthn use COSE algorithm identifiers, which I talked them into doing way back when, so they weren't inventing their own algorithm space, and that's what they do. So there are pre-hash modes for a number of algorithms. For RSA, for ECDSA, you're free to split them up, and indeed some implementations do that. This is a slide which Mike Unsworth let us use by permission. He usually doesn't do that. Where, again, Mike loves signing cat videos too, just like Hank. But why would we want new algorithm identifiers? Why not just use the existing ones? Well, you need a way to signal that what you're being asked to sign as the key holder has already had the previous step done, usually hashing, but again, in the draft, you'll see that there's other forms of pre-steps as well. That way you have a protocol signal that the digester has already done half the work and then handed it off to the signer. Another Mike Unsworth slide. There are some algorithms that are incompatible with this. For instance, EDDSA includes a hash of the private key, or includes the private key in the hash. Well, the digester doesn't have the private key, so this isn't an applicable algorithm. So it is case by case. So we've updated the draft. There's now requested assignments should this make its way to the point where IANA would consider making the assignments. We used an unallocated, or requested an unallocated range, 2-byte range, the 300, minus 300, etc. And more requested allocations. Now, some algorithms do have parameters that would need to be communicated between the digester and the signer because both parties need them. And the draft defines a general context structure for doing that. Sophie, please take it away.
There was a mention of Schnorr signatures. I don't have done the math, but I don't think you can do that in a secure fashion for Schnorr. I think you leak the private key if you allow the digester to query arbitrary things. The way that Schnorr works, you need to do the same thing that MLDSA does of this message representative, which is probably not compatible with whatever Schnorr signatures you have currently.
And I'll give my standard glib response to that. I am not a cryptographer, nor do I play one on TV. I'm glad that there's real cryptographers in the room. I know Emil knows some of the cryptography, but if we're getting some of the details wrong, absolutely inform us.
I do have a paper that I've been drafted like a while ago that I then didn't publish because I thought there was no interest. Mike Ounsworth convinced me that there's actually substantial interest on that. I will try to add Schnorr to the things to analyze for that because I think it might be an example where everything breaks. Falcon is definitely an example where everything breaks. Schnorr, I think, is also one because of like, if you can choose the commitment, that might not be, or if you, I need to analyze it, but I'm very uncertain that is.
Just as a tourist, why does everything break with Falcon?
This Falcon, everything breaks because you can repeatedly query the 0 point. So that is like the way that Falcon works is what's called a hash and sign scheme. Same is true for RSA, where you compute the hash and then you find a pre-image of this hash according to your one-way function. And it uses the fact that this hash, like it uses something called the random oracle model, where to like model the hash, and the hash produces basically random numbers. If I don't do that and then instead ask for it for the signer to sign the point at 0 over and over again, the signer will deliver me shortish lattice vectors one by one until I have enough to do a lattice reduction and reconstruct the signer's private key. So the difference between ECDSA's prehashing and or MLDSA's external mu prehashing and Falcon or Schnorr's prehashing is that in the MLDSA case, there is another hash in MLDSA. You don't see that. It's buried inside the algorithm that then hashes mu to compute some things. And with Schnorr, that would be outside. That is why I'm not certain that it's secure. The difference is that there is a hashes that we just use to compress the message to make it more easy to handle. And then there's a hashes that the cryptographic algorithm uses in order to make them secure. And while the former, you can like do external stuff without any problems, the latter you need to be extremely careful with. It happens to be okay with RSA. You only get a forgery attack with RSA. You do get an attack. It's a forgery attack, and you don't really care about a forgery attack in this context because you have an oracle that you can just ask for the actual signature. You don't care about the fact that I can, in theory, create a signature that the signer never signed by asking it for 2 other signatures. That's not really a relevant threat model here because like I could just ask the signer to sign the thing that I wanted to sign. But you need to be very careful that it's really just this kind of forgery attack and not a private key recovery attack. As soon as you have a private key recovery attack, the threat model of splitting the signer and the digester just falls apart.
You know what I'd love? If you helped us write security considerations.
Yeah, I will work on that paper. I know, like I see that I need to do that. It's like in the weird part where it's trivial from the sense of the cryptographers and very much non-trivial on the sense of the engineers.
The practitioners,
and those are always these things that like
the gaps where stuff falls between.
Gets falls in between. Like no conference will publish that paper that I write. It will sit on ePrint and be happy about that. But like no conference will consider this an interesting paper,
a novel result, but it's an important engineering result.
Yes, I will write it up and then we can hopefully get talk about this.
Merci.
Yeah.
So this is already a slide you have seen. This is about ARKG. So the status slide, I'm being more assertive than we've been before because I think it's called for. The draft is stable. The technique is deployed. It meets, this is the slide where I talked about WW Wallet having won the German Funky competition. The WW Wallet, for context, is a cloud-based wallet. It's not a wallet where all the data lives on your mobile telephone. But if it's in the cloud, you obviously need to secure that data. There's both encryption and signing operations used to secure the data. And those are performed by the authenticator. Yubico has prototypes of this, but again, that's standards track in FIDO and the W3C so that we want everybody to be able to do this. It's not at all proprietary. And this is part of the standards palette to enable interoperable implementations of things of that nature. Emil, John Bradley, I have tried to listen very hard to what people were confused about or surprised about in the past, and we've tried to update the draft to achieve non-surprise. And the warm fuzzy feeling that, oh, this is already something that is known to work. Believing it's stable and needed, it seems logical to ask for working group adoption. At this point, Ivo, it's your meeting. Oh, and Emil's in the queue. Why don't you speak? And then, but Eva will have to decide what the next steps are as my co-chair.
Thank you, Mike. I just wanted to address Sophie's point earlier about the Schnorr signatures. Yes, I agree that that is probably insecure to split in this way. And fortunately, we do not propose standardization of an identifier for splitting Schnorr in that way. So you can rest easy.
Right, indeed, I was going to say that Schnorr was on the slide as an example of a place where it's complicated, and our draft doesn't propose split Schnorr. Thank you, Emil. Ivo, are you able to speak? We do not hear you.
He says just a sec.
Okay, thank you. And we've got loads of time.
Is it better now? Do you hear me?
We can hear you, Eva. Thank you.
Okay, so the usual question, I guess, is how many people have read the draft and is there interest in it?
So I'll decompose the question. Who has read the draft? Lawrence a little bit. He's wishy-washy. I have, obviously the authors have. We should try to get some volunteers to read the draft. Who would be willing to read the draft? Lucas Preble will read the draft. Sophie, would you read the draft? Okay, it's short. Lawrence?
Yeah, this is Lawrence Lundblade. I think this is a good idea, and I support the draft. That's fine, even though I haven't read it too thoroughly. I do have a couple of questions about it, but let's do the adoption discussion before I ask those.
Well, if you've got clarifying questions, it's fine.
Okay, so I didn't quite get why you needed different IDs, algorithm IDs for this. And then the question also is for the other side of it, the verifier. This is indistinguishable from the verifier's point of view. So they, okay, so we've got a good question here.
Oh, okay, so 2 points.
Yeah.
It may be the case that your signer, the party holding the private key, can either sign with the split algorithm or with the non-split algorithm. The operations that the signer would do are different in those two cases. In one case, the digester has done half the work, or 95% of the work. In the other case, the digester has just transmitted the data to be signed. And you need to know which operation as the signer you're going to do. That's why there's different algorithm identifiers for the split signing algorithms versus the, I don't have a good term for it, the one-shot signing. Does that make sense? So that you could signal which kind of signing you're going to do.
Well, there's, before you're doing the signing, you know, instructions to you on what you should do or not do. And then there's, once you've done it, what do you tell people that you did?
In all cases with this draft, which goes to your second question, what you tell people you did was the one-shot algorithm, because the results are indistinguishable. The bytes are the same whether you did split signing or one-shot signing by design. And so the verifier never is told, and doesn't need to be told, whether it was decomposed when being signed or whether it was one shot, because the way you verify it is exactly the same.
So that makes sense to me, in that the verifier doesn't know difference, except there's some mumbling around here in the vicinity that I'll stop talking, let them say. But I guess I'm not sure why you need an identifier as the instruction to the signer in order to know what to do. I mean, is that?
Well, that's what algorithm identifiers do.
Well,
they say what to do.
What's the protocol? I mean, where's the protocol? And is it to me? So.
Well, what the protocol is always pretty much out of scope here, right, but it's in scope for FIDO CTAP. It's in scope for WebAuthn.
Okay, so you have use cases where you're
yes,
really
exactly. Okay. Those bodies, which you're quite aware of, do protocols, and they're using this.
And they care about this.
Yeah, exactly.
Okay, that helps. Thank you.
Sure. No, good questions.
Yeah, just quick. The main algorithm where it's not the same is EDDSA, where you have this EDDSA PH version. SLHDSA has that prehash version as well. Technically, so has MLDSA, but we are all trying very hard to ignore that exists.
So what Sophie said, it depends on whether you consider EDDSA to be or the same algorithm as EDDSA prehash. If you consider them to be completely different algorithms, then yes, it's always the same. But
wow, we've got 4 people in the queue. Emil, you're ahead.
Thank you. Emil Lundberg, Yubico, co-author. And yes, to be very specific about use cases here, the place we want to use this is a proposed WebAuthn extension that we want to use for signing arbitrary data, as Mike mentioned earlier. And in that extension, we need to negotiate what algorithm you use for signing. And if you want to use an algorithm in that case where you want to sign like a gigabyte of data, for example, then it's useful to be able to do the pre-signing on the application level. So in WebAuthn, like on the basic level, in the basic WebAuthn API, WebAuthn already uses COSE algorithm identifiers for algorithm negotiation. And the only part of that algorithm negotiation is a single COSE identifier number. So it would be natural to use the same format of algorithm negotiation in this extension. And the first draft of this extension just tried to specify generally that the data you're signing is supposed to be pre-hashed by the caller. But then as we worked on that, I think we felt already from the beginning that doesn't actually work in general. You can't in general say the caller pre-hashes the data, because as we've gone through, that doesn't work for all our algorithms. And for some algorithms, you could do it in different ways. Like for MLDSA, you could do either hash MLDSA or you can do external mu and so on. There are different options you could reasonably pick for some algorithms. So that's some of the reasons why having specific numbers for specific sets of algorithm steps is a useful thing. And yes, to also answer some of the chat going on here, these identifiers are specifically intended for algorithm negotiation within an application, essentially. So when you are creating the signature, if you need to negotiate the algorithm there, that's when these are used. And these identifiers would not go over the internet to a verifier to be like to annotate a signature.
Scott.
Just to jump on to the bandwagon, EDDSA verifier and EDDSA prehash identifier are two different things. They're not in. They're not.
Yes.
What?
Yes.
Okay, so basically, you need different algorithms, code points to say which one your signer did.
Yes, and to build on to that, even if you're using ED 25519 prehash, if you are the application telling a smart card, for example, hey, please sign this using ED 255 is the smart card supposed to again hash the data one more time and then do the pre-hashed algorithm, or did the application do the pre-hashing step before? So pure ED 25519 without pre-hashing is not possible to separate in this way, but ED 25519 PH is possible to separate in this way.
Yeah, I believe that that exactly who does what is actually specified in the PH ED 25519 PH draft or RFC or whatever it is.
All right, thank you, Scott. I don't see any questioners in the queue. John, did you want to speak? You weren't on screen. Or are we good?
No, I'm good. I was mostly agreeing with Sophie.
Okay. Emil, your meeting. Or not Emil. Ivo, your meeting.
That was quite a good discussion, I would say. I think let's get some reviews on the mailing list, and if everything looks good, I will issue the draft and the call for adoption after that.
All right, thank you all for the good discussions and clarifying questions. And I learned things, so that's always fun. Thank you. One more presentation.
Can you hear me?
Yes.
Better? Okay. So hello, everyone. I'm Göran Selander from Ericsson. I'm going to talk about test vectors for C509. And this is joint work with Leon Liao and John Preuss Mattsson. And it's based off code by Li Jun. So, I mean, basically he did all the work. But he's not here today, so I'm going to talk to the slides. Not working. There we are.
There you go. Oh. There we go.
There we go. Okay, so the summary. The chair has already talked about C509. It's currently in AD review. Thanks very much, IO, for providing shepherding. And there's been requests to make test vectors, and that's this draft. So it contains like 25 different X509 certificates and corresponding C509 certificates with different types of subject, public keys, signature, algorithms, subject attributes, extensions. And then there are also the CSRs and the CSR templates specified in the base specification. But there are no public key algorithms yet. That might go into a separate draft. So I'd like to show you some test vectors, but just a brief recap about C509. So C509 certificates are like X509 certificates. So difference is that you have ASN1 DIR encoding, and in C509 you have CBOR encoding. And also C509 comes in colors, apparently. So you have the blue field, which is the issuer and subject are of type name. And if issuer is null, it's a self-signed certificate. And name is defined on the next slide. In the green field, you have the algorithms, issuer signature algorithm, subject public algorithm, an algorithm identifier is defined on the next slide. And at the bottom, extensions in red. And then in some sort of orange, there is validity, which is the CBOR time encoding. And if not after is null, it's can be extended for forever. But the field that's most discussed on the mailing list is the purple field, which is the versioning. And there are two types of C509 defined for historical reasons called type 2 and type 3, and I'll get back to those. So here is the rest of the CDDL. There's the blue, green, and the red, and they are very similar structures. So I just talk about the last field here, the extension. And extensions, so there are CBOR encoding of extensions defined, and for each CBOR extension, you ask IANA for an integer, and you get an integer. And if it's a negative integer, it's a critical extension. Or if you use it as negative, it's critical. So that's one way of getting extensions into your C509 certificates. Another way, if you don't have a CBOR encoding, is that you take your OID and then use a CBOR OID encoding, and then you have a Boolean critical, and then you have your extension byte string. So the same principle works for both extensions, attributes, and for algorithm identifiers. So now that we know how they work, here's an example. This is a CBOR diagnostic notation of a X509 certificate taken from the IoT profile of TLS and DTLS. That's RFC 7925. So this is 140 bytes in C509, and it's 300 plus in X509. So obviously, if you're thinking post-quantum, then a few hundred bytes might not have a big impact. But there are other reasons why people think this is useful, and sometimes a few hundred bytes is exactly what you want. So this particular certificate, for those of you who attended the dispatch meeting on Monday, Bob gave an account for the aviation industry is going to use type 3 certificates. And I'm going to talk about the other. Sorry. So type 3 here means that this type 3, the first field is a 3, means type 3. That means that the signature is over the X509. So if you convert this back to ASN1 DIR and just copy over the signature, then you have the X509 certificate, and you can use it as with the software you have. And then there is the other variant, which is called type 2, and I'm now flipping back and forth. And the only thing that is differing is the first and the last field. So in type 2, the signature is, so the first field is 2 instead of 3, and the last field, the signature is over the CBOR instead of over the ASF1. So that was a recap of of C509. And now we come to the draft with the test vectors. So this is basically an annotated hex. So you have the X509 and you have the annotated hex of C509. And here with the color coding, you can see what, for example, in the blue field, you see the issuer null. This is a self-signed certificate, and so on. And the column on the left is byte offset. Anyway, so that's the format of the test vectors. Here are the extensions, 4 extensions. That's it on C509. And then we have the similar things for certificate request. So the certificate request, taking all the fields already defined in CBOR, it's very easy to make a PKCS10-like structure, and that's this object here. It also has a purple field for versioning, and otherwise it's very straightforward. Bob, did you want to say something now?
Bob Moskowitz, other than I owe you to go through this, I've got just another request came in for another one. We'll have to support the X520 serial number. Now to see if there's a difference, whether it's in subject or auth subject name, whether there's a difference in how you do that in there, because as you know, we're counting every single byte. So I will be, I will be going through this very, very closely for you on this to help assist on this. Just join into the sandbox.
Thank you very much. Okay, and finally, there is the request template. So that's basically it's a CSR with a number of either empty fields or multiple choice fields, and sent from the CA to the client, and when for the client to fill in exactly one value, and that constitutes the request. Okay, I think I'm done. Well, yeah, here's the example. So there are a number of undefined. We're using the CBOR undefined simple value. Right, any questions, comments? Anyone? So this is a very short draft. I had thumbs up from Bob. It's actually, I think it's 1 page of text, and the rest is actually these test vectors. So, what is the next steps? I think this would be good if we could get this in tandem with the specification.
So it's my assumption that you'd like this to be adopted by the working group.
Yes.
I think that makes sense. Certainly when we were doing Jose a dozen years ago, it made sense to adopt what became 7520, which was the test vectors for all the algorithms. This would improve the quality of implementations. Is there anyone who believes that having test vectors for C509, which is a working group document, was not something that we would support? Is there anybody willing to review the document? Kirsten Borman and
anyone in the chat?
Bob. Okay, I mean, this seems so obvious. Unless Ivo contravenes me, I think we should ask for adoption, and people can review this as part of the adoption.
Ivo also says he will review it.
Ivo what?
He says, I will also review it.
Okay, thank you.
Okay, thank you.
All right, thank you for doing the work. Is there anything anybody else would like to talk to the working group about? We have completed our agenda. We are 20 minutes early, which is fine. That's not always been the outcome for this working group, but we finished a lot of work, which is great. Thank you for your time and thank you for, oh, people are in the queue. Karsten Bormann.
Yes, you should have some slides for that.
It's your time. We're off the agenda.
Yes, you should have some slides for that.
Oh, am I wrong?
Just show the slides. Or I can dig them out if that helps.
Let me see. What's your topic?
Something boring. Registrations for ketchup.
I do not see that.
Called Turbo Kanga something.
That was not uploaded. That may have been share error. Let me see. Kirsten Bormann asked to share the slides.
Okay.
A new deck is being shared.
So I proposed those slides. Maybe you never put them in.
Let me look at my email.
Anyway, I can talk.
Okay.
But it would be nice if you put in the slides because there are some tables there. Okay, one of one of the wonderful things we do in this working group is supervise the registration of algorithms. And there are lots of algorithms that we could register, but specifically it has been pointed out that we are a little low or a little late on the Keccak-based hash and MAC algorithms. And there are two aspects to this. One is that we actually just got a CFRG document published that has descriptions of algorithms for hashing and parallel hashing, actually called Kangaroo 12 for parallel hashing and TurboShake for usual ordinary hashing. And these are in the registry now. However, to get the recommended column be set to yes, there needs to be an IETF consensus document. And since the definition of these algorithms was an IRTF consensus document, that was formally not possible. And of course, that's something that can be easily healed by just having an IETF consensus document that these algorithms are indeed recommended. So this is part one of this document, which doesn't exist yet. And part two is that there are a few other algorithms that are either specified by NIST or are hinted at in the TurboShake Kangaroo 12 IRTF document that would benefit from registration. And that starts by something so obvious as KMAC. We currently don't have a way to do KMAC in COSE, and that needs to be fixed. So these are the examples. You didn't find them?
No.
Oh, okay.
It's not in the console.
That's one part, and the other part is that the TurboShake Kangaroo 12 document from IRTF hints that there are ways to use the hashes defined in the document to do max. And there are actually two proposals in there. One is the hops-MAC set of algorithms. You see, kangaroo, hops, whatever. That is relatively sidechain resistant because it keeps information in memory only for a very short amount of time. That may be important to you. The disadvantage is that you have to hash twice. And the text also hints that you could just hash once by doing the usual prepend key construction for a hash. So you just hash the concatenation of the key and the data that you want to make. And well, the difference between SHA-3, where you just can do that and get good security, and SHA-2 was that SHA-2 is susceptible to length extension attacks. So you want something like HMAC to give you additional security, which is again 2 hashes. So that's the set of things that is going to be in the draft. I will try to make sure that the slides turn up on the mailing list at some point. The draft is not yet actually written. This is because some co-authors work for the US government, so we will have to have a little bit patience. But I think the slides I made are already giving a good picture of what we are trying to do. Of course, we are totally free to put things in there, not put things in there. So that's probably going to be the major piece of work for this draft, simply deciding what should be put in there. Bob.
Bob Moskowitz, let me know what I can do to help you with the hashes of KMAC, particularly since I use KMAC all over the place.
Yeah, so I think this is actually the easiest part of the document, but I will certainly make sure that you get to see it before we send in the first draft.
What are the harder parts?
What is the?
What are the harder parts of the document?
Well, the hardest part is taking the hints from the IETF definition of TurboShake and Kangaroo 12 and actually write down the actual hash algorithms that come out when you follow those hints. So it tells you you can do prepend key or append key. Now somebody has to sit down and find out that prepend key is better because it avoids accidentally splitting the key over 2 rounds.
Let's just ask the KMAC team, and the Ketchuk team. Let's just go to the Ketchuk team over there in Belgium and ask them directly.
They are actually, some people from there are actually involved, yes.
Yeah.
So I didn't want to submit the draft while we have this situation.
Yes.
But I thought I could make slides.
Okay. Again, I'll help.
Great. Thank you. Lawrence, do you mean to be in the queue or can you remove? Yeah, my page isn't responding either. We're having tooling failures.
Okay, that was all I wanted to say. So if you have anything from the Ketchup family that you have been missing in COSE, this would be a good time to tell me.
Okay, Karsten, I don't know if the tooling will let you still update the draft or your presentation to the meeting. If so, I would ask for you to try to do that. I'll send you the place to do the upload, which I'm sure you know how to find, but I'll send it to you. And if the tooling will let us upload it, then it can be part of the official meeting record anyway. Thank you. So Karsten and Lawrence are in the queue, but I believe they've all said their piece. Anyone else, including anyone remote? All right, going once, going twice. Thank you for your time and engagement, both here and since we last met. Fini. Or it's fin, isn't it, in French? Fini.
Okay.